So today's session, we're going to talk more about a tool called Terraform. I think most of you might have been aware, or you might have been already using it. So, uh, you know, let's take for the next 60 or 90 minutes to focus completely about what's Terraform and what is the concept behind using Terraform and what's the architecture. So the agenda is completely to understand how Terraform is going to be helpful for us and what does it solve in our day-to-day activity and why is it one of the important tool in our DevOps culture, right? So that's what I'm going to talk. But again, anytime, any questions that you have, feel free to unmute yourselves and ask. And just to give a small introduction about myself, my name is Adam, and I'm an architect by profession and a technical trainer by passion. Okay, so now whenever we talk about a product, and let's say whether you're working as a developer or a QA person, or even you might be a production support engineer or a database admin. Now, regardless of what kind of work that you're going to do, now for all of us to work together for this project, we need infrastructure in IT, right? So now this infrastructure, primarily, if you see earlier, we used to have it on our on-prem, more on VMs, and then slowly everything has been migrated into cloud. And again, when I say cloud, it could be specific to AWS or Azure or GCP, or even sometimes you might have certain hybrid infrastructure where few services or resources that you will be using from one cloud and few on the other. So in that way, now for us to do our work, let's say like I want to do my testing or I want to set up my production environment, then what do we exactly mean by IT infrastructure? Now, this is where whenever we say IT infrastructure, so it's a combination of a couple of things. That is, the major component what we have is the hardware, and then what kind of software that you want to work on top of this hardware. Like you take a machine, but in that machine, what exactly do you need? And then for your work, it's not just going to be a single machine. So whenever we say our IT infrastructure to do our work, there will be a bunch of machines which we have to connect it together over a network. So network is also one of the important part for us in our infrastructure. And then just by creating a machine and ensuring that we have a proper network communication between them will not be sufficient. Then we also have to make sure that we have proper access to those infrastructure. Now that could be a server or it could be a database, right? Now that's where whether you take your VM or whether you take your cloud, so we have specific identity that has to be created. And in that, we are also going to make sure a proper authentication is given, because creating a user account, for example, in AWS or Azure is different. But what is that person going to do? As a user, if you're going to do some development activity, then there are some policies that has to be applied, which will restrict you to use only certain resources, right? Or if you're going to work more as an administrator or taking care of certain deployment activities, then you need access to certain other services or resources. So that's when, in order for us to use this infrastructure, we also have to enable a proper process through which we will be able to give the authentication. So that's when the requirement that we have now is whether you're working on an existing product for which you have to do a release, or you're going to work on an upcoming release for a new product or for a new feature. Then what happens? You might be required to modify the existing infrastructure that you have, whether it's on your VM or it's on your public cloud. Along with it, we also have to make sure if there is a need, we also have the ability to create new infrastructure. So that's when the focus heavily that what we need is to do our day-to-day work for development, testing, and deployment and production support. There is a requirement for us to manage our existing IT infrastructure, or you might have to create new infrastructure on the need. Now, how do you do all those things? So let's take, for example, even if you're going to create infrastructure in AWS or any similar cloud, it's not going to be an easy thing, because if you have a dedicated administrative team, now first you have to raise some kind of tickets, and you have to follow a process where you have to get it approved. Now, even for a single machine that you want for some kind of development or testing, again, you have to go through the same process. So there is no agility in it, because the single team, like how we have a production team or a admin team, now, by the time they go through all the tickets, it will take at least 2 days for us, even for a simple request. So that's when it's actually time consuming. And the second point, what we have over there is it's not going to be scalable, because even though if I say I need 10 machines, or let's say I need 5 machines and a database in AWS, then as an admin, if you go to that console of AWS or Azure, and if you keep clicking certain buttons or UI, it's actually a procedural way that you're doing step by step. So that workflow is again time consuming, right? Now, this is where when organizations are adopting to concepts like CI/CD or continuous deployment, now we need the infrastructure to be available as soon as possible, because that is the first, primary responsibility that we need to make sure. Only then you can start working on your development or testing or deployment. Now, for this, how do we make sure that on the need basis, you will be able to scale your infrastructure again, which could be the existing infrastructure, or it could be completely new. Now, going through all this manual process will definitely be time consuming, prone to error, and it will be difficult to scale. And the other important thing that we need to focus on, especially when we are working on cloud, by mistake, if you try to over provision or create too many machines, or if you try to select the wrong type of a service like a machine or a storage type, then the cost that we're going to pay for that will be high. And at the same time, if you're not deleting or purging all the unnecessary resources or services, once again, even that will cost us a high. So that is where the problem statement that we have as part of our DevOps culture is, how do you take care of your infrastructure management? Now, typically, whether it's on AWS or Azure or GCP, right? Now, regardless of all these things, how is that efficiently you can manage your infrastructure, which would be what we call it as cost effective, and it's less prone to error, and how do you scale them at any time that you need? And top of all of them, we call it as the tool or our solution that we are going to give to overcome this problem should be a cloud agnostic way. Cloud agnostic way means whether I implement this solution for managing the infrastructure on AWS or Azure, it should be almost the same. So these are the challenges that we face in our development or release activities in order to manage infrastructure. Now, how does it look? Now, let me talk a little more technical. Now, let's say that we have decided to do our deployments using containerization. And for that, we are going to use an orchestration tool like Kubernetes. So once again, whether you're going to have your self-managed Kubernetes, or whether you're going to use a managed service like EKS or AKS in AWS or Azure. Now, for the product, first, you would be going through the development phase. Now, at that point of time, if you want to do the unit test or you want to do some smoke test, then you have to set up a cluster where you have to define the things or the infrastructure requirement for your master component and then the worker components. And then you need to set up a network over that and start working. And same way, when your development phase is complete and now you're ready for your full-fledged functional testing or regression testing. And then if you want to create a cluster again, which is of the same type, but the only difference will be the machine type and the resource will be different. Because let's say for the development, you might have taken 4 GB, whereas for your QA, you might need a 8 GB machine. So then it's almost the similar infrastructure. Immediately, how is that I can create another cluster with just some variation in the configuration of my infrastructure. So that's where going through the manual process, like what I was explaining earlier, in the traditional way, it'll be time consuming and it'll be prone to error, right? Now, in the same way, let's also look at a complete network. So now for me, let's assume that I have a front-end application which I need to run in a machine. Now, even though I say that, okay, I need to create a server, or I'm going to create two servers, and inside that, I'm going to run my application. In real time, your infrastructure on cloud will look like where you will have a separate virtual network, like in AWS, we call it as a VPC. So first you need to make sure that you have a proper account, and inside that you have your network created. And within the network, you want to also make sure that there is a particular set of rules or the traffic will be allowed. Now in AWS, we call that as a security group. So now, even before you create a machine, you need to make sure that within this network, you have a proper security group, which will have the rules to allow the inbound traffic and the outbound traffic. And then from there, you're going to create your machines. Now, once again, to create a machine or more than one server, you need to particularly choose the type of AMI or the machine image based on your OS. And then you need to tell the type of the server, like how many CPUs and RAM. Plus, you're also going to tell on what is the storage that you need, and particular other things like the network associated to it. Hey, I'm sorry, is my screen visible? Okay, I'm sorry, I thought. Okay, I'm just, okay. Now, as we move further, once again, it's not just about the servers, but again, let's say that when you have more than one machine, you might need a load balancer to access. So once again, for me, this is how infrastructure will look like. Even for a small application to run when I need a machine. Now, when I say infrastructure on AWS, I need to create a VPC and then a security group and then a load balancer. And under that, I'm going to create machine with all the configuration. Now, this is where what exactly happens, and the problem that we have is whatever the process that we are following, or in the traditional method of using the AWS console or the CLI, everything is imperative. So imperative means you have to tell all the steps what you have to do one by one. Okay. So this is the first problem that we are going to solve, right? And the second thing is this is not scalable, because that's what I was telling you on the previous slide. You might have a cluster set up for dev, and the same thing if you want to replicate it for QA, you can't just get it in a matter of time. So once again, you have to go through the same process of setting up everything from beginning. So that's when the traditional method is not scalable. Or maybe I can put it up in this way. The solution that what we are looking at is how do you ensure that there is a scalability for managing your existing or new infra. And the third point, what we have is called as mutable infrastructure. Now, especially to understand this word called mutable. Now, what happens if you try to take a machine? Now, you first create a machine, go inside and install some services or packages. Now, after some time, you once again go and upgrade that OS, or you upgrade any package or install some new package. So this way, everything that you keep changing inside the machine happens in an incremental way. That means you take something which is already available, and on top of that, you're going to keep on modifying it, right? So by doing this way, your infrastructure is called as a mutable infra, because when you keep changing everything in an incremental way, you do not have a history of what got modified and when it was modified. And the meaning of mutable is you cannot go back to a previous state of the machine or the infrastructure. So this is where if I ask you, hey, can you take the machine back to what you had 2 weeks back, wherein exactly you should be having the machine with the proper OS update and the package, not all the things what you had now. So there is no easier way for us to revert back. So that's when the infrastructure that generally we are creating are more of mutable, where we keep on adding and modifying on top of what we have, and we do not have a history. And this is where the requirement what we have is, as we move towards continuous releases and continuous deployment, what we need is a immutable infra. So immutable infra means we should be able to track our entire infrastructure, and we should be able to go back to any level of our infrastructure, and we should get everything that we had at that particular point of time. So basically it is like you have the ability to recreate your infrastructure at any point of time. So such a kind of infrastructure, what we need is called as immutable infrastructure. Okay. And this is where finally what happens. Now, there could be one service that you're using in one cloud service provider, and there could be another service for us to work, which will be on a different cloud service provider. Now, there are certain tools that you can use to automate it, but we don't have a single tool which helps us to automate the infrastructure across various cloud service provider. So that is what we technically call it as cloud agnostic. So considering the problem of infrastructure management, so now what is that we need? We need a solution which helps us to work in the opposite of imperative, which is declarative way. And we need the ability to do the scaling, as well as we need the ability to do the opposite of mutable, which is immutable infra. That means you can go back to any level of your infrastructure and recreate it. And then what we need is the ability to work across multiple cloud providers, which is what we call it as cloud agnostic. So considering all these as the use cases, now one of the tool which is quite popular in the market, which works on all these concepts, which is a declarative way, and it also helps you to scale the infrastructure, and mainly it works on the concept of immutable infrastructure, and such a tool which can work on both AWS or Azure or GCP. So that's what we call it as Terraform. Okay. So now if you look at, so Terraform is a infrastructure automation tool. So using which you can create or build your new infrastructure, or you can also modify your existing infrastructure. And at the same time, you will be able to have a track of what and all are the changes that is happening to your infrastructure. So how does that work? Or what's the concept behind how Terraform is going to help us to do all those things? Now that's where Terraform works on a concept called as infrastructure as code. Okay. Now, infrastructure as a code, or IAC. Now, what does it represent? So now imagine you need an infrastructure. So that is an example of the AWS that I was showing you. Now, for me to do some work, I need a account in AWS, and then I need a VPC, inside that security group, and then load balancer, and then a machine and a database. If this is my requirement, then what infrastructure as a code tells is you convert your requirement in terms of a state. That is, you give this input through a means of a code. So when I say code, it's not a program, it's some sort of syntax through which we will be able to tell Terraform on what is our desired state of the infrastructure. So which means now you're going to tell Terraform in some kind of a code or in kind of a syntax, where the syntax will tell, okay, I need in AWS a particular VPC,